Hi class, this is Sir Alex again. Welcome back to our lesson in General Physics 2. Today we are going to continue on with lesson 4. We're basically going to do last two more sample problems in order to understand how we use the superposition principle. Previously we discussed how we use the superposition principle to solve the net force that Q1 experiences because there are two other charges in its vicinity. So there's Q2 and Q3, and they're kind of like in a line. So that's much easier to solve. So this time we're going to look at some problems wherein what if our charges or our charged particles are not in a straight line. So let's get straight to the sample problems. Let's just move on here. There you go. Okay, so let's look at our sample problem here. So from here, you would see that instead of having three particle or three charges with different charges, here what we have is basically three charges is still, but we have, as you can see, identical point charges. So what we have here is kind of a little different. Moreover, as you can see in the drawing, they're not in a straight line, they're forming a triangle. So let's read the sample problem. So there's three identical point charges with charge Q is equals to 3.0 times 10 raised to negative 6 coulombs. So all of these charges here share the same charge, so they're all equal in charges, and they're placed at each vertex of an equilateral triangle. So if we look at some words here, so these are our charges. They're all positive signs, and the charge is 3.0 times 10 raised to negative 6 coulombs, and are placed at each vertex. So do not get confused. What vertex means? It just simply means the corner of a triangle. So these charges are basically placed at the corner of a triangle, and more specifically, an equilateral triangle. So that just basically means the side of the triangle are all equal. From the word equi means basically equal, lateral means side. So all of these sides right here are in equal distance, and the distance is 0.01 meter. So let's start writing our given. So first we know that all our charges are equal, and the magnitude of charge is basically 3.0 times 10 raised to negative 6 coulombs. And all of these charges are placed at the vertex or the corners of our triangle. And we know that the length of the side of the triangle is 0.01 meter. What that tells us is that these charges are basically separated at a distance of 0.01 meter. So that tells us that our d is equals to 0.01 meter. So now we have our q and we have our d. So that's all our given. And what is being asked of us is basically find the resultant electric force. Don't get confused, resultant just means the total force. Okay, so this is basically your net force, your total force. Okay, and we're looking at the total force that the charge found at vertex A, so basically our QA. So what does this QA experience because of QB and QC? So we are looking at F total. We are looking for at F total that QA or Q found at A experience. So that's what's being asked of us. Next, let's identify the formula that we have to use in order to solve for this problem. First, we note that the formula that we have to find is basically also the Coulomb's law, because according to the superposition principle, in order for us to find the total force or the resultant force that QA experience, we have to identify the force that QB and QC exerts on QA. That basically means kailangan natin hanapin yung total force na ginagawa ni QB kay QA. So in order for us to solve for that, that's basically Coulomb's law. So that's F is equals to K multiplied by Q1 or times Q1 Q2, the absolute value, divided by the square of their distance. Moreover, ang hinahanap din natin is F total. We're also looking for the total force that QA experiences because of QB and QC. In order for us to do that, we just have to add the vector sum of the forces that QB and QC does to QA. But unlike the first example that we have, unlike the previous sample problem that we have for point 1, um, our Q1, Q2, and Q3 are in a straight line. So it's much easier, we just have to add. But this time we are in a triangle. So I will explain later why we are going to use this equation here, but this is the equation that we have to use for looking for F total. So basically what you want is find the sum of all the forces at the x-axis, square it, and add it to the sum of all the forces that is in the y-axis, square that, and then find the square root, add those two together and find the square root, and that's how you find the F total. So I will explain later why. Okay, so we have now all our given, our ask, and our formula. Let's head on to our solution. Okay, so the first thing that we have to find in order for us to find the net force is we have to first find the force that QB and QC independently exerts on QA. So let's begin by finding the force that QB exerts on QA. So we're looking for basically FB on A. And we know that we have to use the Coulomb's law in order to find this. So QA, QB divided by B squared. So basically just plugging in the numbers. So K, again, it's just a constant. You just have to remember the value of K, which is 9 times 10 raised to 9. That's Newton meters squared divided by Coulomb squared. That's the Coulomb's constant. Next, we have to multiply the charges of QA and QB, their absolute values. So we have to remove any negative if there's negative signs. Gladly, we don't have any negative, and they're the same values. So that's basically 3.0 times 10 raised to negative 6 coulombs multiplied by 3.0 times 10 raised to negative 6 coulombs. All of those divided by the distance between QB and QA, and that we know is 0.01 meters. So that's 0.01 meters squared. So we know that our column squared here would be cancelled because we have two columns here. And since we are squaring our m, we cancel that. That also cancels. We're left with newtons, which is the correct unit for this case. And we know that this is actually equal to 810 newtons. Next, what we have to find now is the force that QC exerts on QA. So that's FC on A. And again, in order to find this, we just have to use Coulomb's law. So there you go. So we have QA and QC all over D squared. So the square of their distance. And interestingly, because this QA, QC, and QB are all the same value, and our distance are not actually changing, so we're basically using all the same values. So we know that this is supposed to be also 810 newtons. So easy enough, right? So yes, why is it 810 newtons? It's because basically it's all the same values. We are using the same D as we use in FB and A. We're also using all the same values for QA and QC. And we're using the same constant value for K, so we will ended up with the same exact number. So that's how we find the force that's QB exerts on QA and QC exerts on QA. So now that we were able to find the force, let's now find the total or the resultant electric force. Remember, to find the F total, you have to do a vector sum. It's basically a vector addition. And since we're talking about vector, we have to consider the direction of our or basically the direction that our charges are, that this charge is experiencing. So if we are going to draw this, let's say we have our QA here, and we know that QB is here, and we also have our QC here. Okay, so what happens is that we know that all of these are positive, right? How do we know this is positive? Because their charge is positive. And we know that positive repel, or same not positive repel, same signs repel. And since QA and QB are the same sign, so the force that QB does on QA is towards the opposite direction, so meaning it wants to push it away. So the force that QA experiences is going towards this direction. So this is our FB on A. Now let's look at the force that QC exerts on QA. Since this is our QC right here, our QC is also positive. Same sign with our A. What that means is that QC is also pushing away, sorry. So we know that QC is also pushing away QA. So this is our, let me just fix that. There you go. It's a rough drawing, but that's basically how it should look like. So this is our FC on A. So this is the force that C exerts on QA. It's pushing it away. So this is the direction. And if we're going to draw a Cartesian or coordinate plane, so this is our plane right here. Let's put our A in the region. So this is your positive Y. This is your positive X right here. This is your negative X right here. So as you can see now, the direction of our forces are not in line with our coordinate plane. Does that mean it's not directly in the positive y-axis and it's not directly in the positive x or negative x-axis? This is our negative y here. So how are we going to find the vector sum? This is where we have to go back to our discussion of, if you guys remember, we have to go back to our discussion of vector addition. What we have to do is find the component. What we mean by component, since these are not directly in the line of our coordinate plane, we have to do a component. So meaning we have to break down the direction of FB into FY and FX. So if we look at FB, we know the direction that is towards the positive X going this way. So this is basically your FB on A in the X direction. Moreover, our FB&A is also going upward in the positive Y direction, and this is basically your FB on A in the Y direction. The same thing is true for our FC on A. So this is the Y direction of our FC on A, and this is the direction for our FC on A in the x direction. And as you can see, it's going towards the negative x direction. So that's basically a negative sign right there. So this sign right here, this negative sign right here is just telling the direction, and it's going in the negative x direction. So after we identify this y and this x, what we have to do now is to do a component. And what we're going to do is we're going to create a table. Let me just move this right here so we can have a space. There you go. Okay, so what I'm going to do in order for us not to get confused, I'm gonna do a table. So I'm gonna write my forces here. I'm gonna write horizontal, and I'm going to write vertical. So Horizontal is basically your fx, meaning the direction of the x component of these forces. That means this direction here. And in order for us to solve for the value of our fx, what we just have to do is basically have the f value of the force, the magnitude of the force, multiplied by cosine theta. Our vertical component is basically the Fy, so meaning these directions right here. So the direction of our forces going in the y direction, and they're both upward. And in order for us to find the value of this Fy, we just have to get the value of the magnitude of our force and multiply it with sine theta. So that means is we need an angle. So we have to identify the angles here. How are we going to do that? Let's go back to our triangle here. We have an equilateral triangle. We know that the angle of a triangle is 180 degree. And since all of these are the same equal signs, so these are 1, or at least 0.01, 0.01, and 0.01, what that means that the angle here are actually all equal. So what we're going to do is basically 180 degrees divided by 3 because we have 3 equal angles, and that will give us 60 degrees. So our angle here is 60 degrees, and according to basically vertical axis theorem, the angle here are actually gonna be 60 degrees. So our angles here are 60 degrees. Now that we know our angles, we can find our forces, our components. Okay, so let's begin with FB on A. We know that FB on A is equals to 810 newtons. In order for us to solve for the x component, this component right here, the x component of our FB and A, we just have to take the value of the magnitude of the force of FB and A, which is 810 newtons, and multiply it with cosine to whatever angle is here. That's cosine 60 degrees. And that is actually equal to 405 newtons. Now let's solve for the Fy. We know that in order for us to get the Fy, we just have to take the magnitude of the force, which is 810 newtons, and multiply it with sine, the angle, which is 60 degrees. And that is actually equal to 701.48 newtons. So now we're able to find the x and the y component of FB on A. Now let's look for FC on A. We know that FC on A is also equal to 810 newtons. So in order for us to find the Fx, that's also basically going to be the same. F 10 newtons cosine 60 degrees. But wait, what would be the difference? As you can see here, this is our FC and A, right? This is the direction of the force that QC exerts on QA. In order for us to find Fx, what we have to do is find, as basically this is going in the negative direction. What we have to do is basically gonna do this, which gives us 405 newtons, but as you can see the direction is in the negative x, so this should be negative. So our fx is negative. I hope that's understood. This is positive because it's going in the positive x direction. This is negative because this is going in the negative x direction. So for Fy, we also have 810 newtons. This is, we're using the value of FCNA multiplied by sine 60 degrees, and that is equal to, yeah, that is equal to also 701.48 newtons. So now that we have all our component, what we just have to do is take the sum. So this would be our sum of our fx. So this basically 405 newtons plus negative 405 newtons. That's basically 0 newtons, because plus and minus, that just means we're minusing it. And we also have to take Fy, which means 701.48 newtons plus 701.48 newtons. That will basically gives us 1402.96 newtons. So that is our Fy. What we have to do next is to find our F total. So this is our F total now. And in order for us to find that, we just have to do this. Our Fx squared plus our Fy squared. And that is equal to 0 squared plus 1402.96 Newton squared. And this is actually equal to 1402.96 Newton. So that is the total force experienced by QA. And what is the direction? Well, we can identify the direction here. We know that our Fx is 0, which means there is no direction going in the x direction. It's all going towards in the y direction, and it's in the positive sign. So the total F force is actually going here. So this is our F total. So our direction is upward. So that's how we solve for the F total if we have three charges, but our three charges are all in our three charges are in a, let's say, triangle situation. So the this is the I hope, or I hope you guys understand what just happened. If you guys have any questions, do not hesitate to message me. But there's just a little recap. In order for us to solve for this, what we have to do is first find the independent force that the individual charges are exerting on our target charge. So our target charge here is QA. We're looking for the net force that QA experiences. Hence, we have to find the force that QB exerts on A and find the force that QC exerts on A using our Coulomb's law. And this is we find it, or we this is what we did here. After finding that, you have to identify the direction of the force, and that's what we did here. Since we know that our QB is positive and QC is positive, it means they have repelling force because our QA is positive. So the direction is opposite the direction of QB and QC. We ended up having this direction for our FC on A and FB on A. After identifying the direction of the forces, if the direction of the forces is not straightly on the x or on the y axis, what we have to do is find the components. So break down the components, find the y directions, and find the x direction for each of the forces. And after doing that, you have to solve for the horizontal and the vertical component. Horizontal component is basically the x component. Vertical component is the y component. After finding all of that using our equation here, Fx is equals to F cosine theta. So just taking the magnitude of your force multiplied with cosine theta for our horizontal component. The same thing for vertical component, only multiplying by sine theta. After doing all of that, you just have to add them, and after adding them, you can now find the F total using the Pythagorean theorem. Okay, so how does this make sense? Because if we actually use a graphical method, if you guys remember how to solve using graphical method, so this is your FB on A, and in order to solve for, what do we call this? In order for us to solve for um, the resultant force or the net force of these two sources right here, we just have to add the head tail method. So take one and then take the second one and place the tail of the second one to the head of the first one. So this is your F, B, and A, and this will be your FC on, no, that's a little too big. And this is basically your FC. It's a little too big, but yeah, so something around here. And this is your FC on A. So this is the graphical method, and after doing that, you just connect the tail of the first one to the head of the second one, and this is your F total. And that makes sense. As you can see, the direction of our F total is also the same. You can use this if you want, but this is just easier right here. Because if you're going to use this, you have to know the measurement of these ones. And okay, so I hope that's clear. If you guys have any questions, do not hesitate to message me. So we're gonna end the video for part 2 because my recorder is having issue. If I go over for a very long periods of time, it doesn't save. So for the sample problem 4.3, it will be the different video. So I hope you guys understand what just happened. Again, if you guys have any questions, just please message me. Thank you so much.